All right. Understand how R and Z change when added or multiplied by a constant. You guys remember where R and Z come from?
Like Z-score.
Yes, perfect. Yep, Z is the Z-score. The Z, it is the number of standard deviations away from the mean. And R, you guys remember what R stood for? What the name of R is? Yep. Yeah, the correlation coefficient. Okay? Of a linear model. Now, what happens if I multiply all the data by 6? When we multiply by like a constant 6, how does that change the R or the Z?
Z shouldn't change.
So,
I don't know about R.
okay, Evan's saying Z should never change. What about R?
R and that is constant, right?
Yep, that's right. Both of them never change.
So whatever you do to data, what you say.
That is correct. And they never change because they are standardized. That is why the only way to actually compare two things is to find their Z-score. It would not be, I could not say who the better athlete was, Jordan or Alex, because maybe,
definitely Jordan.
well, Jordan's specialty might be soccer and Alex's specialty might be baseball. And so we can't really say who's the better athlete unless we compare the two. I'm just saying. Okay. Understand positive and negative association. I think you guys are all okay with that.
Wow, football.
Positive.
Yeah,
I could go.
terrible at baseball.
I'm sorry.
I wasn't even going to play this year.
You gotta play golf. Yeah.
Okay, so either they both go up or they both go down. That's going to indicate a positive association. A negative association is when one goes up and the other goes down, or X goes down and Y goes up. Okay, so they're opposite. They work against one another. All right. Okay. May I flip? Not yet? Okay, sorry. Oh, sorry. Yes, we are. We're on that last page, then I'm going to get to the questions. Okay. All right. First thing, explanatory variable. Which one is that, guys? You're going to be able to have to read. Yes, that is the X variable. There is an X in explanatory. Bless you. No, there's not a Y in response, but it's in the beginning. That's how I can do it. Okay, the correlation is the R. And the only thing that I want to caution you guys, and also R equals the square root of R squared. But make sure that this is a decimal. They're going to give you R squared in a percent. Change it to a decimal, guys, and then figure it out, okay? All right, and R squared is down there, and we're gonna talk about that. I'm gonna go through that, but that's the percent of change, and we'll get to that in a minute. And don't forget that if the slope is negative, R is negative. Okay? All right. Now, association. If I say to describe the association, what are the three things that we want to talk about?
Center should be red.
No.
Okay, like how strong it is.
Okay, so
Whether
strength.
Positive and negative.
Strength, form, direction. I was
Got the
totally
word.
Comes alive. Strength, form, and direction. Okay. Strength, what are words that we're going to use for strength?
strong and weak.
Strong. What's in between? Moderate. And then form. What do we typically use to describe the form? Linear. Or sometimes it could be quadratic. And then direction is basically positive, negative, or no direction.
Wait,
Okay? Okay, and please remember, you guys, if they say in context, please use some of the words from up above to describe the association. Don't just say the data is strong. Just say that there's a strong association and actually say between and say what the Y data is and the X data is. If it's, the temperature outside and the amount of clothes that somebody is wearing, okay?
Excuse me. You're not mine.
Michael Lau?
Okay, so now we're going to talk about slope. Slope is just your rate of change. Okay, y-intercept, I'll give you these notes. Okay, is the initial amount.
Remember to plead the fifth.
All right,
What?
It means you can stay quiet.
okay, initial amount.
Talk.
Let me do an example. Okay, so let's say we've got this equation, and I say describe the y-intercept in context, okay? Well, it's going to be the initial amount. That means the way that you would describe this y-intercept in context. Does anyone want to give it a shot?
No, I was really confused on this.
already at 23 when you started.
That's right. In this particular case, before you even, let's say you're buying something, and it's $1.50 a pound. That's what this means. Before you even buy it, you've got to pay this initial upfront fee of $23.50. Don't know
What
why.
is that?
I have no idea. I'm just making this up.
That must be a really.
But that's the initial, before you even buy anything, that's what you have to pay. It's a club. You want to get into the club, I guess. All right, and then these are really fancy almonds, okay?
Fancy almond club?
That's the fancy almond club. All right, so now the slope, you guys, the slope is always y over x. So it is $1. It's for every $1.50 you spend per 1 pound of almonds, okay? Got it. All right, everybody's good with that. R squared. Probably not the best example. Remember, it is how you describe it in context. It is you would say the percent of variability in the y variable, yeah, can be explained. How? By the linear model. That's the short way to say it, and that's fine. Residual, that's going to be E equals y minus y hat. That's just the individual pieces of data. Basically, it is observed minus predicted. A negative residual means that your observed is below the line. So if you want to, I don't know if you want to do a quick sketch. If your dot is down here, then this has a negative residual. And if your dot is up here, it has a positive residual. You get them mixed up? The tricky part is if it has a negative residual, then the predicted line is an overestimate because it's above it, it's over it. If it has a positive residual, then the predicted line is an underestimate. Okay? All right, you have to know the requirements. We're almost finished. About 4 more here. What are the requirements of an experimental design? You guys have done these before? Experimental design, people.
I'm scared of the answer.
No, you can just, I'm sure your answer will be fine.
Randomized?
Yep, randomization.
Well, thanks, Thomas.
Okay, randomization's one of them.
Control group.
Yep, control group. Okay, and the other one that you must do is you must have replication. Okay, I cannot just do an experiment on one person and say, yep, that's the way it is. No, you have to do it on more than one person, okay? You have to just, yeah. I mean, if everybody, if I just asked me, you know, what is your opinion of math? Oh, it's the greatest subject in the world. Yep, then it is. No, I would probably have to ask a few more people. And we probably wouldn't get that same. Now, you could have blocking, but that's not necessary.
Sounds like the ocean.
Okay? Okay, do you guys understand the law of large numbers? Do you know what that is? Okay. All right, law of large numbers, you guys.
Law of large numbers.
The law of large numbers says the more times something happens, the closer to the true average you get. For example, I could flip a coin 10 times and get 3 heads, 7 tails. If I flipped a coin 100 times, I would probably get closer to my 50-50. If I keep continuing to, the more times I flip a coin, the more times I get closer and closer to the true percent that I get a 50-50 shot of getting a heads or a tail. Okay? That's the law of large numbers, the more times you do it. The other one is the law of averages. All right? This does not exist. It does not exist. The law of averages says that you're due to win. No, you just need to understand that. You need to understand that, well, if I rolled a 6 3 times in a row, then I'm probably not, I don't have as good a chance of rolling a 6 again. No, you still do, guys. You still have a 1/6 chance. Okay?
Oh.
That's what that means. Yes. Right now?
We got a huge win conference.
No, well, now that's a little different because of, what you do is you play around with,
We can never win it.
I'll hear you state
no, just use it.
We
I'll get you some
can
afterwards.
It
do-
doesn't
All right,
exist
26?
because the events are independent, right?
You need to know,
Okay.
what? Yes, that is correct. Because the things are independent, that's right. Know how to make a probability model and know if it's legitimate or not. If it's legitimate, then the percents equal 100% of your model. Probability model looks something like this. And let's say, I don't know, I've got the probability of spinning a 0, 0.1. Probability of getting a 1 is 0.3. The probability of getting a 2 is 0.5. Then what's the probability of getting a 3? 0.1. Because they all have to add up to 100 or 1. All right. Understand about and or, and know the rules. The probability of A or B equals the probability of A plus the probability of B.
I have a question.
Is there a lot
Yes.
of counties in-
Are we gonna have to find the mean, variance, and standard deviation of probability model?
No, like from chapter 17?
Yeah.
No, chapter 17 is not on this exam, only up through 16. Okay? So those, the binomial distribution, geometric and normal, that is not on there.
Probability is not on this.
There is some probability, but it's this simple probability. Venn diagram, possibly,
Is
okay?
there a lot of that?
No, there's not a lot. Well, it's right here, see? Down at the bottom. Unit 4 had probability. There's 7 questions from it. 5 multiple choice, and there's 1 extra credit. So,
How much is multiple choice and how much is your response?
a worth per se,
No, like how many questions?
right here. It's on your paper at the bottom here.
Oh, look at that.
Yep, Unit 1 has 6 questions, and 4 of them are multiple choice. 8 questions, 4 are multiple choice, 9 questions. That's why in the last unit with the probability, there's 7 questions.
Is the extra credit multiple choice?
I can't remember, sorry.
You put it in that section. So there's like.
I did, so maybe it is, one of them is extra credit. So if you get it right, bonus, you don't get hurt by answering that one.
Oh, that's 25%. 29 is 150
Just suggest reading the book.
The reviews at the end. I would just suggest the reviews at the end of the book. That's a great way to start.
What you said.
Yes, if I would do this, yeah. Because what I've done is I've taken and chosen some problems that would be helpful, okay?